So we all know that there are different types of payment pages. And depending on the type of payment page, attackers are using different methods to be able to skim the credit card holder data. They have been evolving their methods, and at some point it gets confusing. So my goal for this tech demo is to basically clarify all of this for you, and hopefully you will find it useful. But before that, let me properly introduce myself. I'm Pedro Fortuna. I'm CTO and co-founder of Jscrambler. I'm also a member of the BOA of the PCI SSC. I've been working in security for 20 years, the last 13 of which I've been focused in defending websites from integrity attacks, script integrity, all of that. And I do talks on a regular basis, but this is actually my first talk at a PCI event. So the agenda for today is pretty straightforward. We'll just get out of the way some core concepts and ideas. Then we'll go through a series of scenarios, of attacking scenarios that we're seeing, and how you can think about mitigating those types of attacks. If we have time at the end, we'll see a live demo. If not, I invited you to swing by the Jscrambler's booth, and we'll be happy to show you. And that's it. So starting with what is skimming? So there's multiple ways you can be attacked with an skimming attack. Perhaps a third-party component is compromised and you happen to download that script, or maybe the website backend has some vulnerability or misconfiguration, and it all leads to some part of the website being compromised. And that leads to usually a web skimmer running on the websites, and the purpose of that is to capture the credit card holder data and exfiltrate it to the attacker. So why should we care? It's just one credit card that got stolen. Actually, in the old days, in the security world, we used to think that, okay, I just care about the database. If I get breached, that will be massive. It's the whole database that gets stolen. But you have to think about, if people are following the PCI requirements, actually what they will find is properly encrypted data at rest. So it will be garbage for them. Okay? On the other hand, on the client side, everything is in the clear. The credit card holder data was not encrypted yet, and if they are able to inject a skimmer that will run in every user session, this can result in a massive data collection. In just one day, millions of credit card data could be stolen, and it's unencrypted. So because of that, the PCI DSS v4 introduced 2 new skimming requirements. I will not get into this. You have heard about this even today, other talks. Basically, you have 2 requirements, 643, 1161. You have to make sure that all scripts executing on the payment page need to be authorized and properly justified, and their integrity is ensured. And also to have a mechanism to detect change and temper of scripts, and to have alerts on all unauthorized changes. And the scope of that is the payment page. But what is the payment page? Well, you have different types of payment pages. You can have a payment form directly on the website. Okay? So you will be responsible for collecting and storing and securing the credit card holder data. But you can also iFrame the payment form. This is a cross-origin iFrame. And a variant of that is every field will have its own cross-origin iFrame, sometimes referred as hosted fields. And these 2, in particular, they have been growing in popularity because basically people was just trying to delegate away the need to be PCI compliant to the payment service provider. Okay? That used to be the case, no longer true. So now we have found that the parent page can actually lead to leaking of credit card holder data. So now according to SAQA, those 2 requirements, 643 and 1161, are also applicable to the parent page. Okay? So you cannot make these requirements go away that easily. One thing that I get asked all the time is, with these two new requirements, that means that the number of third-party scripts, or scripts in general, on the payment page and especially on the parent page are reducing. Are they? And my answer is no, quite the opposite. With the current economic climate, what we're seeing is the business is pressured for results, and they need all the help they can get. And that usually is through inserting all sorts of vendor scripts to analyze how the user is behaving and all of that. So we're seeing that the parent page is becoming more and more populated with scripts. But my main goal for today is basically to make sure that I update you on the different types of attacks according to the payment page. So on iFramed payment pages, we see iFrame overlay or iFrame hijacking attacks. If it's a payment form directly on the website, we see regular skimming attacks. And in both cases, we see form overlay and fake forms being injected into the page. Let's go through those using a number of different scenarios. But let's start easy with like a regular canonical skimming attack. Okay? So in this type of attack, it affects the payment page, as you know. What happens, one script will get compromised. At some point, will attach itself to the event of a form, so that when the user clicks the submit button or the pay now, they will collect all the information and exfiltrate this information. In terms of mitigation, you can use, in theory, you can use CSP, especially SRI, for that, to prevent a script from being modified. But actually, we now know, and most of the industry is coming to the realization that this is unpracticable, especially because of third-party scripts. They change all the time. You are not notified of that. And to make things worse, when they do, you didn't update the SRI hash, which means that the browser will silently block that script from loading, and most likely the page will break and you will not take payments. Okay? That's good if it's a schemer, but that's very bad in like any daily change of that script. You can also use a scanner in the sense of an automated browser that will visit the website. We also call it a bot. It can potentially detect the schemer code, but there's all sorts of barriers that scanners need to face. For instance, they do not necessarily know how to navigate to the payment page automatically for any given website. Someone needs to do that manually at least once. And they do not reach every corner of the website automatically. So you have to configure that, and you have to maintain that. And also, some schemers are known to use bot detection, so they can avoid manifesting itself when they think that the session is being driven by a bot. The agent, on the other hand, which is a script that we give you, and you can insert it on your pages, on your payment page, or at least on your parent page, can detect all code behaviors, in theory, and block any of these behaviors. But for this attack in particular, the vendor needs to be monitoring event hijacking and/or access to forms enabled to prevent a schemer. Scenario number 2, form overlay. As the name suggests, what happens is now the attacker is not even targeting the real form. So monitoring the real form does not help here. Okay, so what we need to do instead, I'll get to that in a second. Before that, let me explain the attack. So basically, some compromised script will basically create a new form and will perfectly align that new form on top of the real one, so that an unsuspecting user will basically enter the data in the overlaid form, not on the real form. So to mitigate the SRI, it basically maintains the same restrictions I've mentioned before. The scanner can potentially, it's the same, so maintains the same restrictions, the same barriers, and the agent is able to detect and block this type of behavior, but only if the solution supports monitoring of form-related behaviors, like restricting if a script is able to create a new form or add it to the page. At any of these points, it's an opportunity to block this type of attack from happening. Scenario number 3, a fake form, very similar to the previous one, but in this case, the attacker basically creates a new fake form, but not to overlay the real form. It can actually use any page, like ideally the page just before the payment form can be used to display a fake form. And if the user is expecting that form, it will probably give their cardholder data away. Okay? So as you can see, in the script will create element fake form, we'll set an attribute with the source, and we'll just add it to the page. In terms of mitigation, everything as before as the overlay form, but in this case, in this case as well, the vendor needs to be monitoring form-related behaviors. Again, the mitigation strategy is the same. If you can restrict a script from creating new forms on a page, which most scripts shouldn't be able to do. You know, like any page might have a form or two. You know what these scripts are. Why shouldn't you block other scripts from creating forms on these pages? You should. Scenario number 4, iFrame hijacking. This is one of my favorites, very clever, and this applies to the parent page, okay? So in this case, you usually delegate to a payment service provider. They will give you a script, and that script will dynamically add an iFrame that will load the payment form inside that iFrame. This is a cross-origin iFrame, so it gets isolation from the main execution environment. But in the case of iFrame hijacking, what happens is before the payment service provider loads the script, they will do this attack where they monkey patch the HTML iFrame element .prototype.set attribute. So monkey patch means providing a different implementation of a function so that anyone afterwards, if they call this function, they will call the replacement function. They will not call the original implementation. So what they do is this is kind of a man-in-the-middle attack applied with functions. So this new function basically waits out if the set attribute is applied to the source attribute, then they will just ignore the source attribute and replace it with the evil URL. Okay? So later on, when the PSP is creating the iFrame, the same way as before, the source attribute that will be set in this iFrame will be a different one. So the attacker can leverage this by just rolling out like a clone of the payment form on a different domain. And this is applied to the parent page. In terms of mitigation, you can actually use CSP in this case. So frame source or even child source will create an allow list of domains where you accept to load a cross-origin iFrame from, and this is quite effective. The scanner potentially can detect this attack, okay, if they are monitoring, if they are also monitoring things related with iFrame creation and iFrame set attribute, as well as the agent. But the agent can block as well. Okay? This all depends on the capabilities of the product. So I'm speaking generically. Okay? So you always have to check what they support, what they don't support. The more behaviors they support, the more likely it will be that they can be effective in preventing this type of approaches. Scenario number 5, iFrame overlay, very similar to the form overlay, but using an iFrame. So you'll get the gist of it. So basically, the PSP will do what it does, adds the iFrame with the payment form, but the attacker will later add a perfectly overlaid iFrame on top of that. So if you're monitoring the real iFrame in some way, you won't catch this. Okay? It's the same thing as the form. If you're just monitoring the real form, you won't catch fake forms or overlaid forms. The same thing for iFrames. So to mitigate this, it's very close to the previous example, CSP is effective in doing this. Anything with framing, the browser is actually, with the help of CSP, can prevent this. And the same thing for scanner and the agent, okay? And again, the agent needs to be monitoring iFrame-related behaviors, like creating iFrames or changing anything about an iFrame, source attributes, anything, or relaxing an iFrame with the sandbox attribute, relaxing the behaviors. And last, we have script usurpation. This is a quite exotic type of attack that actually only affects scanners and agents, okay? Why? Because in this type of product, they usually work by having policies or rules that describe what behaviors they either alert or accept, block. And these rules are like, if it's script X doing this certain action, then it's okay. Any other script is not okay, and I will need to generate an alert, okay? So it's all predicated on the script's identity. And this attack, script usurpation, is basically an abuse of the script identity. So consider this example. You have form process, and you have one function called autocomplete. It doesn't matter what it does for the sake of this discussion, but what it matters is that this function is executed every once in a while, in this case, every second. Okay? And this form process is a privileged script. It means that as per the scanner or the agent, this script will get away with creating iframes, creating forms, doing other things. No alerts will be generated, no blocking. It's a privileged script. Now, any action will be approved. So now, consider this example. Compromised scripts will monkey patch the autocomplete function. So this is different from the previous example where I referred monkey patch, because before we were monkey patching a browser DOM API. Now we're monkey patching a custom script function, and it's different how you go about it. And in this case, we're monkey patching, the attacker is monkey patching the autocomplete, and inside the function, it will insert whatever behavior it wants to get through, but can't because it's not a privileged script. So they monkey patch. Now autocomplete becomes this new function, and they just wait for this function to get called again. They cannot call it directly. It gets called. The function that will execute is the monkey patch version, and now the action of getting the credit card value, and in this case, exfiltrating this data through Google Analytics gets through, because these products will think that it was the privileged script triggering this action. Okay, so it basically abused the script identity of the privileged script. In terms of mitigation, since this problem is not applicable to CSP, it doesn't matter, but I threw in a little thing in there where I used Google Analytics to exfiltrate the data. Now, CSP is very ineffective against this because, like, any website will approve Google Analytics as a network source kind of allowed domain. So we are seeing more and more schemers exfiltrating the data to, like, domains that people usually approve. So that is making the network source directive of CSP non-effective to prevent exfiltration. In fact, I consider exfiltration to be an impossible problem to solve. Okay? I think that you need to prevent access to the data, otherwise it won't work. And the scanner or agent will fail against this attack. And what you can use, in addition, that will make it effective is combine that with code hardening. So code hardening is basically rewriting the code to make it tamper resistant or to become protected against monkey patching. So usually, privileged scripts are first-party scripts. That's very common. So you control those scripts. You control when they are changed, when they are built. So you can bring on code hardening to your build system and make sure that it is protected against monkey patching of those functions. Okay, but Not every code hardening solution has this ability, so check for that. I will skip the demo because I don't have the time for that. So my last slide, there are 4 ideas that I want you to take away with. First of all, skimming attacks are going beyond simple skimming of the payment form. The parent page or even other pages can be used, can be abused, and can be targeted, and they can end up resulting in leaking of that data. Third, securing payment data properly requires more than just controlling where websites load code from or what domains they send data to. This is what CSP gets you. For example, controlling forms, access to forms, creating iFrames, manipulating iFrames are just as important behaviors to control. And finally, securing payments at scale is done better by monitoring new behaviors and authorizing them only when they increase the risk level. But beware of the dangers of script usurpation, because this set of products can be vulnerable to that type of approach, as it can help bypass monitoring rules. So protect against monkey patching. That's it. Thank you.